Okay, here we are. We've got a function, and we're trying to find the slope at x equals -1. That would be the instantaneous slope at a point. So we're going to set up a difference quotient and find the limit. We need to pick 2 points. So my first point is going to be the point -1, f of -1. That would be the point that I'm trying to actually find the slope at. And then I need a second point, so I'm just going to go slightly away from that, -1 plus h. And then f of -1 plus h. I'm going to call this my x1, y1. And then my second point, my x2, y2. And I'm going to go back to slope formula from Algebra 1, which is y2 minus y1. So that's me taking this minus this. It's going to look like this, f of -1 plus h minus f of -1 over x2 minus x1, so x2 minus x1 is going to be -1 plus h minus -1. And because I want to find the exact slope exactly at x equals -1, I'm going to use what I know about calculus, and calculus allows me to say, hey, I'm really going to take the limit as h is approaching 0, because then my 2 points, if h were 0, then my 2 points, this would really just be a -1, and this would really be f of -1, and my 2 points would be on top of each other, and there we go. I found the slope at the point, which is exactly what I want to do. So I'm coming right back to this, but I want to, and I'm going to substitute in here, I'm going to do a little work on the side to figure out f of -1 plus h and f of -1. So f of -1 plus h is me going back to my function right here, and I've got square root of -1 plus h, just went in for x, and then I've got this plus 3 that was there. Simplifies to square root of 2 plus h. And then I've got f of -1 is the other thing I need to know, because I'm going to put that right here. So that's going to be square root of -1 plus 3 comes out to square root of 2, which is almost a nice number. Not bad, at least I don't have the h's there, but not something that you really want to work with. So I'm back to here, and I need to rewrite this. I'm ready to substitute in. So I'm going to substitute in, and I'm now going to have, I still have that limit part. Let's not forget about that. Limit as h is approaching 0 of fraction. My numerator, f of -1 plus h, is the square root of 2 plus h. F of -1 is radical 2. So I've got minus radical 2. And then -1 plus h minus a -1 in the denominator. That ends up being plus a positive 1, and then I've got a -1 and a positive 1 that cancel each other out, and I'm just getting an h in the denominator. Okay, that's not looking too bad, but I'm going to have to figure out how to evaluate that. If I plug in a 0, because we are doing a limit, and the first thing that we always try when we're doing a limit is we substitute in the value. If I try taking the 0 and substituting in for h, and h, I'm going to end up with square root of 2 minus square root of 2, which gives me 0 in the numerator over h is 0, 0 in the denominator, and I get 0 over 0. And we know that that's a problem, and that's not going to get me the answer. So I'm going to need to do something. Think back to what we did sort of at the beginning of the chapter. What might you be thinking we could do since we have radicals? How could we simplify that? I'm thinking we can't factor, so if you're thinking something, I think I gave you a hint, multiplied by the conjugate. That's going to be what we need to do. So the conjugate in this case, let's see if I can clear my screen a little bit. The conjugate in this case, to try to avoid my 0 over 0 case, conjugate is going to be the same thing I have in the numerator, except we're going to change the sign. So this is going to be a plus sign. So it's going to look like this, square root of 2 plus h plus square root of 2. And because I've got a fraction, I don't want to change the value, I have to multiply by the same thing in the denominator. So initially it's going to seem like we're complicating things more. Remember, we have a binomial times a binomial in the numerator. 2 terms times 2 terms, and then I've got h times this binomial in the denominator. So I'm going to let you go ahead and take it from there, multiply it out. The numerator should get simpler, that's why we multiply by the conjugate. Denominator is going to be kind of ugly, but as long as we don't get 0 over 0, we're happy. So go ahead and work that out and see what you get. And again, we're just looking for a number besides 0 over 0. I will say that you are going to have a radical in your answer. That's okay, as long as you don't get 0 over 0.